My name is Maxim Dounin, and I'm an NGINX developer. Today I will talk about new features introduced in NGINX recently. All these features can be found in the NGINX changes file as present in each NGINX source code tarball. And if you are using binary packages and don't have a copy, it is also available on nginx.org website. And here is how it looks on the site. It documents all user-visible changes in NGINX and actually is quite readable, or at least I hope so. In some cases, however, interesting information can be found in this file between the lines, and in this talk I try to help to read it as well. First of all, let me reiterate NGINX versioning details. All NGINX development happens in the mainline branch, and these are versions without second numbers. The latest mainline version is 1.15.5. To help people who don't want to upgrade often, we also have stable versions. This maintains stable API and only get critical fixes measured from the mainline branch. The latest stable version is 1.14.0. I personally would recommend using latest mainline version because it's production ready and usually the best available version. But if you depend on using third-party models, you may, however, prefer latest stable instead due to stable API, because not all third-party models are upgraded quickly if there are any API changes in NGINX. Here is how usage stats for various NGINX versions look like. As you can see, most popular branch is the latest stable. Many are, however, still using older versions. This is not really a good choice, and it might be a good idea to upgrade. And today we will talk what you will get after the upgrade if you upgrade to one of the latest versions, either to latest stable or to the latest mainline. So we will talk about the changes developed in 1.13 branch and available in the latest stable, and changes introduced so far in the 1.15 branch. Let's start with changes in 1.13 as available in the latest stable version. First of all, we've introduced basic TLS 1.3 support. TLS 1.3 is a new TLS standard developed recently to replace previous versions. It was just published this August and actually very new. From performance point of view, it provides two most important improvements. Full handshake now takes only one RTT instead of two in most cases. And there is an early data mode on session resumptions, which adds 0 RTT to a normal TCP connection establishment. In NGINX 1.3, in NGINX 1.13, you can enable TLS 1.3 using the SSL protocols directive. It is not enabled by default. It works with OpenSSL 1.1.1. And in NGINX 1.13, there is only basic support, no early data yet. Note though that in many cases, or rather in most cases, it won't work out of the box with your browser because standard is very new and support in browsers targets some early drafts or disabled by default. It is also worth to mention that it is very easy to break things by incorrect configuration. For example, by configuring an elliptic curve, which is not supported by the client. And here's an example of configuration I recently seen breaking configs with TLS 1.3. We also enabled renegotiation with backend servers, introduced SSL client escape cert variable, which simplifies passing client certificates to backends, and changed code, so TCP no delay socket option is now set before the SSL handshake to prevent latency issues with TLS 1.3. And we also added a model to mirror requests to an additional location. It can be used for analysis, statistics, or testing. And here is an example how to configure request mirroring. Internally, mirror uses background sub-requests, originally introduced for cache background update. Mirror sub-requests are executed in parallel with main request. Note that if a sub-request is slow, it can delay main request finalization and delay other requests on the same connection. As such, it should be understood that mirroring to a dead backend is a bad idea. By default, mirror will read the request body. If it's not what you want, for example, if you're using unbuffered request body proxying, this can be disabled using mirror request body directive. While working on the mirror model, we've also fixed an old problem affecting proxying of sub-requests when there is a request body, and also introduced a new request processing phase pre-content. This phase is currently used for try files and mirror, and can be also used in your own models. Also, we've added HTTP2 server push. It allows to proactively push content to clients, and when used properly, it can improve latency. Note though that push can also easily make things worse, and on average, it's what it does. Here is a link to a talk by Brad Lassie. Push is easily misconfigured to actually introduce additional latency. To enable push, you can either explicitly configure resources to push by using the HTTP2 push directive, or you can enable automatic pushing of resources listed with link rel preload headers. The latter option provides an easy way to control pushed resource from backends. Also, we've introduced gRPC proxy model, which allows proxying and balancing gRPC backends. While gRPC is based on HTTP2, there are some nuances, such as gRPC requires response trailers to be used. And since gRPC is one of the main reasons we were asked to introduce HTTP2 with backends, we've decided to provide gRPC proxy instead. As such, this proxy is specially tailored for gRPC. In particular, it uses no request or response buffering. So it can be used with gRPC streaming out of the box. To keep code simple, it currently provides no request multiplexing, so each request uses its own connection. And much like with other proxying models, by default there is no keep alive. Persistent connections can be configured using upstream keep alive model. Here is an example how to configure simple gRPC proxying. Much like with normal proxying, you just define a location with gRPC path instead of proxy path. And here's how to configure keep alive. In the upstream block, you just use the keep alive directive. And some minor changes. CPU affinity can now be tuned on Dragonfly BSD. CPU cache line size detection now tries to use information provided by the OS if available. So things are improved for non-x86 platforms. In the zip model, we've changed memory handling to be compatible with optimized zlib variants, such as one from Intel. It is now possible to configure socket buffers in mail and stream models. Host names can be used in set real IP from directive. To simplify various investigations when logging signals, NGINX now logs speed of the process. which sends a signal. 3 or 8 redirections are now properly recognized by the return and error page directives. And NGINX can now use capnet row capability on Linux, so you don't have to run worker processes under root if you are using transparent proxying. We've also added SSL pre-read LPN protocols variable in the stream SSL pre-read models, so it is now possible to route connections to different backends depending on the protocols supported by the client. Escaping and access logs can be disabled now, and sub-requests in memory designed long time ago for the SSI model now can work with arbitrary responses, not only proxied ones. This makes in-memory sub-requests much better tool from development point of view. In particular, it is now used for NGS scripting. By the way, Dmitry Volentsov will be giving a talk about NGS tomorrow. I encourage you to attend. Range request from an empty file now return 200 instead of 416, which is better for the slice model. And for timers, NGINX now use monotonic time if available in the OS, so there will be no more weird timeouts on system time changes. And we now support proxy protocol version 2, so you can use NGINX behind Amazon NLB. All these features were developed in 1.13 branch and available in the latest stable. And now 1.15 branch, things we are working on now. We further improved TLS 1.3 support, fixed backend session reuse with TLS 1.3. Now TLS 1.3 can be used with boring SSL and not only OpenSSL. And now we support early data mode, so resumed TLS connections will not require any extra round trips for the handshake process compared to simple TCP handshake. Early data can be enabled using the SSL early data directive. But keep in mind that early data mode provides no replay protection, and this might be important in your case. The SSL early data variable shows if we are working with a request from early data and thus without replay protection, or handshake is already completed. We've also improved SSL configuration checking, so it should be harder to shoot your own foot by configuring things incorrectly. Now NGINX is able to detect missing certificates in configurations with listen SSL. And we also finally deprecated the SSL directive because it makes trivial to break things as in the configuration on the screen. In the stream model, we've greatly improved UDP proxying. Previously, UDP proxying assumed there will be only one packet from a client. If there were two or more, these packets were proxied independently, appearing as completely unrelated packets for the backend server. This is okay for simple protocols like DNS, but doesn't work for complex UDP-based protocols. Now, NGINX tries to look up an existing UDP session when a new UDP packet arrives. If a session is found, this packet will be sent to the backend using the same socket, so these packets will appear related to the backend server. This allows proxying complex UDP-based protocols such as DTLS and also much faster when there are many packets from the same client. It is, however, only works when the packet arrives to the right worker process. So you have to either use single worker process or ensure that packets are directed to the proper process using the listen reuse port. By the way, listen reuse port now works on FreeBSD 12. In the stream SSL pre-read model, we've added SSL pre-read protocol variables, so now you can route a connection to a different backends depending on if it uses SSL or not. For example, on the screen you can see a configuration to route SSL to one backend and everything else to an SSH port. We've added a new balancer, random. It is faster than round robin when there are many backends, and provides the same quality if there are many front ends, so mostly in clustering environments. And another balancer, random with two choices. It uses random to select two servers and then uses the one with less connections. This approach is almost as good as listcon, but again, more efficient. Also, we've changed the reset timed-out connection directive to apply to return 444 to save kernel memory and sockets when closing connections. And we've introduced limits in the upstream keep alive timeout to prevent a race with connection closed by backend, and keep alive request to ensure that connections are closed at some point, releasing memory allocated from the connections pool. All these features were introduced in 1.15 branch so far, and we are currently working on more things. And that's all. Thank you. Any questions?
What kind of new things are you working on at the moment?
Oh, sorry.
What kind of things are you working on at the moment? Any bigger
one of the features we are currently working on is dynamic SSL certificate loading. And we are also considering various other things. Yeah.
What would be your recommended OpenSSL library?
Which version or which library?
Which library?
It's actually a hard question. Previously, I preferred OpenSSL because of the proper development with versions actually available. But after recent work on early data support, I tend to think that in many cases, boring SSL is also a good and very thoughtful library, which provides easy-to-use interfaces. But this is from a development point of view mostly. And actually, boring SSL has its own limitations when used with NGINX. For example, you can't use multiple certificates with boring SSL. So I don't know which to use actually. My personal choice right now is OpenSSL. And I would say that I prefer 1.0.2 or something like this, but it won't. Doesn't have TLS 1.3 support, so probably the most interesting version now is 1.1.1. But I would expect there will be problems in this version. Any more questions? Thank you.